Hello everyone, I'm Xin Xiang Ju from University of Chinese Academy of Sciences. Today I'm going to talk about our recent work, Holographic multipartite entanglement from the upper bound of n-partite information. The motivation of our work is to investigate the multipartite entanglement structures in holography, which is a very complex area without universal measures. In this work, we analyze the multipartite global entanglement, one type of the multipartite entanglement which independent of the pure partite entanglement, symmetric under the exchange of the subsystems, and measure the pure quantum entanglement instead of the classical correlation. We found that the n-partite information satisfies those three conditions when it reaches its information theoretical upper bound. So, what we have to test is whether the n-partite information could reach the information theoretical upper bound in holography or not. Specifically, we first analyze the upper bound of -I3 when AB is fixed and region E is arbitrarily chosen in order to investigate the tripartite global entanglement which AB participates in. However, directly evaluating the upper bound of -I3 is difficult. Instead, we stipulate three constraints for region E as follows, and prove that given a configuration of E that does not satisfy these constraints, there always exists another configuration of E that satisfies these constraints, with -I3 not less than the former one. So only analyze the configuration of E which satisfy these conditions are enough to evaluate the upper bound of -I3. Okay, I will skip the technical details of the proof here. Finally, under those three conditions, the formula of CMI or -I3 is greatly reduced. Moreover, those three conditions also constrain its value from being too large. We give two examples here. The first one is where A and B are two boundary subregions of an asymptotic ADS spacetime. Through specific analyzation, we found that the upper bound of -I3 approaches 2 times SA, which coincide with its information theoretical upper bound. Another example is the two-sided black hole geometry where A and B are two small boundary subregions on each side of the CFT boundary. In these cases, we found that the upper bound of -I3 is given by twice of the Sproat area. Those are very surprising examples, which indicates that there are no bill pairs existing in holography, and all bipartite entanglement emerges from the tripartite entanglement, and any two small distant subsystems are highly tripartite entangling along with another system. For more general cases, we give a most general upper bound of -I3, which is the quantity we named the entanglement of state-constrained purification. Comparing to the entanglement of purification, EOSP we define constraint A' and B' to be boundary subregions instead of mathematically consistent subsystem which purifies A and B. Okay. We then investigate the upper bound of 4-partite information when we fix region ABC in order to investigate the 4-partite global entanglement which ABC participating in. Through similar conditions, and after some tedious technical details to prove them, the 4-partite information is greatly reduced. And after the evaluation, we found that the upper bound of 4-partite information is always finite in ADS3 CFT2, but it could be infinite in higher dimensional holography. This reveals the fundamental difference of the multipartite entanglement structures in different dimensions. That is, the 4-partite global entanglement could be dense among 3 random regions ABC in higher dimensional holography, but it must be sparse in lower dimensional holography. Thank you for listening.